Good morning. My name is Pawane Ayanda. I'm going to teach you on how to solve the limits of the derivative using L'Hopital's rule. We use L'Hopital's rule if we have obtained an answer which is 0/0 or infinity over infinity or minus infinity over infinity, because the 0/0 or infinity over infinity or negative infinity over infinity is stated that the answer is undefined. So I'm going to give you an example of the functions which can obtain infinity over infinity. For example, first example is the limit of f of x as x approaches c is equals to 0. Okay, then the next example is another example. It says the limit of f prime of x all over g of x as x approaches c is equals to 0. These are the examples of the functions that can obtain us an answer which is undefined. So now let's go to giving examples with the numbers. Okay, we're giving examples with the numbers. For example, let's say we have asked to calculate the limit x approaches infinity of x squared all over e to the power of x So let's get to how are we going to solve this question. Okay, we're going to how are we going to solve this question. The question says the limit of x squared over e to the power of x as approaches the infinity. So on how to solve this one, we have to first differentiate x squared. By differentiating x squared, we are finding the derivative of x squared. So the derivative of first s squared, the first derivative of first s squared. Okay, let me go like this one. The first derivative of x squared, the first derivative of x squared, dv of x squared is equals to 2x. Okay, then let's go to e to the power of x. E to the power of x is equals to, we have to drop the power first. Okay, the power, but we're writing constant powers, so for us to differentiate the e to the power of x. So what is the constant? The constant of x, which is 1. Then we multiply that constant by e to the power of x. So that means the first derivative of e to the power of x is equals to e to the power of x. Is equals to e to the power of x. Then there we go. We still have the limit as x approaches infinity. As x approaches the infinity of, now we're writing these obtained answers that we got. We have 2, whether it was x squared, we're replacing with 2x, all divided by e to the power of x, which is the first derivative of the function. Okay, let's go to the next point. Still, we have x, but we have to have a constant on the numerator. We have to obtain a constant. So that means that we are going to differentiate again the 2x. We are going to differentiate it. So now it means we are finding the second derivative of this function. finding the second derivative of this function. How do we find the second derivative? Second derivative of the function is equals to, when we differentiate 2x, it is equals to, when you differentiate 2x, it's like, guys, when we differentiate 2x, we obtain a 2. Then we'll go again, we differentiate e to the power of x. When we differentiate e to the power of x, we can obtain a 1 and the term e to the power of x, of which it gives us e to the power of x. Okay. Now we have to write this function again, but on this function, we are writing what we have obtained. So it's still the limit of the infinity. As x approaches infinity, of 2 all over e to the power of x.